Here's our second video on elimination. So a lot like the last problem, if I were to add straight down the two equations, I would get 6x. The y's would cancel, so they're eliminated from this equation, and I would get 36. Divide by 6, and I quickly find x is equal to 6. However, when I try to use subtraction, I get 2x minus 10y equals -8, I believe. Nothing cancels, and I just have this other equation. So not much I can do there. So what I'm going to do is I'm going to take this second equation, and I'm going to force the coefficients to be the same. So how am I going to do that? I'm going to multiply that bottom equation by 2. And when I do that, I get 4x plus 10y equals 44. Now if I take my top equation and put it right below that, now if I subtract the x's will cancel. 10y minus a negative 5y was really addition, so 15y. And then 14 from 44 is 30. And I can quickly just divide by 15 and get y equals 2. So there's my y value. My x value was 6. My coordinates of the point of intersection are 6, 2. And it just so happens, kind of a neat little side note here is, well, first of all, I would plug those in and make sure that they worked. So 6 times 4 is 24, minus 5 times 2, which is 10, would give me 14. And I'd also double check it in the second one, and of course it works. But one thing that I think is pretty neat, when I plug it in here, 6 and 2 there also makes this equation true. So it's this other equation is a third line that also passes through that same intersection point.